freight efficiency with NACFE's Mike Roth and Friends.
Here in episode 110, we have joining us Mike Rowand. He's an energy and electric transportation consultant, and we talk about his career with Duke Energy, his work now with EPRI, the Electric Power Research Institute, and his role as an interface between the utility and the trucking industries. He also talks about what utilities need to know about trucking and about grid readiness. He explains the role of communication and collaboration and how fleets can help utilities do a better job of serving them. Hello, welcome to this episode of my podcast series. I'm really excited to talk to a good friend of mine, Mike Rowand. He is an energy and electric transportation consultant. Great to have you on, Mike. You spent a career at Duke, and I don't know if there was a few other places, one of the major utilities in the U.S. and forward-thinking one, but thanks a lot for joining me today.
Thank you, Mike. I'm looking forward to the conversation.
So you got to be a friend to be here, Mike. So do you remember how we met?
I was trying to think about that as in preparation for this, and I can't remember the exact same time, but I know it probably was related. My first exposure to NACFE, I believe, was at the World Truck Week Green Truck Show in Indianapolis, probably close to 10 years ago.
That would make sense.
Yeah, I assume that's when it started. I remember going by the NACFE booth, and I think it was Dave Schaller I was talking to, and it was like, "Oh, a utility person here? We need to talk to utility people. Can you be on a panel?" It was, maybe you moderated that panel. I don't remember, but I'm sure it was around that time frame.
Yeah, so we started our work on electric trucks in 2016, a bit quietly, and then 2017, Elon Musk had his big announcement, and that sort of brought some electric truck like skunk works development at the truck OEMs really out in the open, because he was claiming he was going to be in production in a couple of years, and a 250,000 truck that would go 500 miles and not have a weight penalty, and some of his promises have come to fruition, but many not. But that kind of started the electric truck stuff that we're seeing today, which is really exciting, and we're going to spend some time on that. But I know early on when NACFE got into it, we learned quickly that we were going to have these new relationships between utilities and trucking fleets that really didn't exist. So we're going to have to create a collaboration from scratch. Tell us about, let's just go back and hear a little bit about Mike Rowand. What's your education, career, what makes you tick? And then we'll get into, what's going on today in the trucking industry.
Well, I was born and raised in North Florida. Went to the University of Florida. I'm a fourth generation Florida Gator. I actually had one of my great grandfathers was a student the very first year UF opened in Gainesville. So my UF ties go way back. But being from North Florida, I did not want to move to South Florida when I got out of college. And so I ended up in the Carolinas, co-opted with Duke Energy, worked at a nuclear plant at Duke Energy. Then decided when I came full-time after school, that was a co-op operation. I went to other parts of the company, and I didn't join Duke expecting to spend my entire career there. Ended up over 37 years, but the way I like to describe it, I worked for 5 different companies. They all just happened to be Duke. There have been so many changes in the industry. I had such a varied career. Every few years, I was doing something different. I spent time in distribution engineering, building the lines that go down the roads and in your neighborhood. I spent time project managing transmission substations, the large substations at large facilities. Most of my career was around things related to commercial industrial customers, energy utilization by commercial industrial customers. I managed groups that looked after, determining the way we were going to serve the customer. Do we serve from distribution or transmission? What size equipment do we need to put in? Do they need any special considerations? What rates do they need to be on? So I did a lot of work with innovative rates through the years, real-time pricing and things like that.
Yeah, sure sounds like that prepared you for what's coming with trucks and data centers. And
it did, and it really brought together. There was a time in my career, kind of got to a point where I had one of those careers where they said if something that didn't really fit somewhere else, they kind of said, well, let's let Mike take a look at that. And until about 20 years ago, when the Volt and the Leaf and those things were coming, there started to be an EV vibe. And I said, I had personal interest, but then it's also, hey, Mike, start looking at this. So that led to kind of where I am now. That the last third of my career or so was in really emerging technology, with electric transportation being the primary emerging technology. But I managed a group that did our early testing with stationary storage on the utility grid, and some of the early solar and things like that. So
I kind of feel the same way. I was at Cummins in international truck for 25 years, and I felt like the same way. I mean, there was like times in my career where, maybe somebody had the job for a long time and they needed a new person to run something. That happened in vocational trucks at International, and happened with a big job I had on reliability and quality at International, where just needed somebody new to come lead the group or just think differently about things. And so I had an attitude, but maybe you did the same, as if somebody else thinks I can do the job, then who am I to disagree with them, right?
it is interesting, as electric vehicles came into my sphere of influence, or whatever, at Duke. And then especially with the medium and heavy duty trucking, with the tie to commercial, it's like, I remember this day I had the feeling that, it feels like the first 23 years of my career was just training for what I'm getting into now. And especially with the fleet, medium and heavy duty fleet electrification, all the things I did with commercial industrial customers, and everything from site selection. I was driving around the BMW site in South Carolina before it was even announced, so everything from site selection to the rates to how we're going to serve them to the service issues, power play, all those things that I've been doing really gelled into this brand new market. And so that's part of why this has been so interesting to me. It feels like, the first 2/3 of my career was just training.
That's a great setup for my question I wanted to ask you, and that is, you did retire from Duke, and but I remember talking to you about your pending retirement, and I could just tell you weren't ready to leave things. So you describe it as you were training for this time in your career. Why did you decide then to kind of do that post Duke?
I call myself semi-retired right now. So I am doing some independent consulting with EPRI, as you mentioned, being the primary person, a group I'm working with. But I did not want to fully retire, but I did want to have more time for things I do at church, for travel, for my grandkids. I have 9 grandkids. So I wanted to have some flexibility. But at the same time, where we are in this industry, it sounds like you've reached this point, and I remember talking to people at Duke. I felt like I had a good bit of influence in the industry being at Duke. Duke, is one of the largest utilities and very involved and progressive in many ways. So I did think I had some influence in the industry being with Duke. But there comes a point where you realize, all right, is there an opportunity to actually now have more influence by being not at Duke? So as I was retiring, I'd had that conversation with people in the past, and it felt like, that's kind of the situation. At the same time, EPRI was launching EVs to Scale initiative, which is around getting the utility industry ready for really full electrification, and what that means from a load and power standpoint. And Britta Gross, which some of your listeners may know, had just joined EPRI, and I'd known Britta from her days at General Motors. So people may not realize, so 20 years ago, when the Chevy Volt was getting announced and the Nissan Leaf, these auto OEMs really started engaging with utilities, and Britta led that for GM. And so I had known her for many years. There was a time we were on the circuit panel back in those days, and we started joking that one day when we were at a new place, we were going to switch, and I was going to pretend to be the GM person, and she was going to pretend to be the utility person, and we could give each other's pitch. We never quite pulled that off. But when Britta was joining EPRI about the same time I was leaving Duke, and she called me up and said, "Look, we're starting this initiative. We really want a fleet influence." I've been doing the last several years at Duke, I've been doing primarily fleet and trucking things. So she said, "Why don't you help us out with this and really be on point for some of these fleet conversations and engaging with the trucking industry?" So it really was a nice fit in timing, and nice fit what my interest was, and the flexibility they have.
You and I were on Sirius XM together about a year ago, and Mark Willis interviewed us, and I remember him saying, "Well, you're the two Mikes of electric trucking." And I was like, "Well, I was kind of shocked to hear him say that, but even since I kind of feel as when I think we're both a couple modest guys that ended up kind of on the forefront of this electric truck freight work. You're kind of the point person on the utility side. I might be somewhat of a point person on the trucking side. And how does that feel for you? I mean, it's exciting, but it's also pretty damn daunting, isn't it?
I mean, it wasn't intentional, just kind of happened based on some of the things I was doing at Duke and the transition to EPRI. And there's obviously other utility folks who are very influential. People like Cedric Daniels at Alabama Power for many years. Many people know him. And so there's a lot of work that's gone before. But I guess right now, and especially with the EPRI work, that's kind of been a little bit of the way it's happened. I've actually described that to all through my career. My mother-in-law always said, I still don't know what he does at Duke. So when people ask, what am I doing now? One of the ways I've described it is, well, I'm kind of an interface between the utility industry and the trucking industry in this electrification journey. And I said, it's a real interesting place to be.
What's something about the utility industry that, in the freight movement, fleet, trucking side, we should know, but probably don't? I mean, what's like the unique special stuff in the utility side that we ought to know?
When you think about the importance of reliability and safety, and we're both core infrastructure needs for the economy. So you can't afford to mess up without a lot of consequences. So a lot of the questions we get, I don't know how many times I've been asked in the last number of years, is the grid ready? Can the grid handle all this? The answer to that is yes, but, and I guess it's kind of the way I would say it. If you think about it, way I've talked about in the past, if you think about past a large electrification, whether it's the post-World War II home electrification or central air conditioning in the 70s and 80s and the internet coming, and that's why the electric industry exists, is to provide power for the economy, and especially as different technologies electrify. But one of the things that makes this so interesting is truly this is a different type of load than any of those other past electrification needs. Been around the industry 40 years, and there's not a precedent for some of the things that are going on. And just to illustrate a few of those, for example, the industry's processes and planning and everything was built around structures, buildings, homes, which have longer timelines. If somebody's going to build a multi-megawatt factory, the utility, there's 2 or 3 years of timing to get everything ready and do the planning and get loads there, get the lines and the power systems there. A company now can add a couple megawatts of trucking power, and the trucks can be delivered in 4 to 6 months. And the infrastructure behind that is a lot less than on the customer side than what a large building would be. So now utility processes that are built around structures and buildings that generally you have a couple years, even a home, you have a year on most cases.
Yeah.
Now that timeline has been compressed. So, and obviously nobody can buy a truck and have it sitting there with no ability to power it. So that is stressing some of the systems. The energy density, this may be one that's maybe least appreciated. The energy density, especially at existing facilities, the load increase that there's really zero precedent for. Some of your fleets may not realize, but if you take 50 or 60 Class 8 trucks and you electrify them based on your duty cycle use cases, that may be the load of the Empire State Building. So if you thought if you were going to call the utility and say, by the way, I'm building the Empire State Building on my replica, full size, full load replica of the Empire State Building on my site, you would have expectations. Okay, they may need some lead time. They're going to have some things to deal with. But from a power standpoint, if they're calling up and say, I'm adding 50 Class 8 trucks and I'm going to be charging them at 150, 200 kW, you've in essence said, I'm adding the Empire State Building to my site.
Or yeah, and I could get those trucks. I could get those trucks in 6 months, maybe 3.
Yeah. And another just a data point, an existing truck stop today from an electrical load standpoint is Jeremy, I stopped at a local truck stop a year or two ago just to say I looked at the transformer size and everything. So this truck stop was, between 2 and 300 kW, kilowatts of power to serve that. Most estimates on a fully electrified, if you did fully electrify a truck stop and it had to serve nothing but electric trucks, it'd probably be in the 20 to 30 megawatt range. So that's a 100x load increase, power density increase on the exact same footprint. And there is zero precedent for that type of load density increase in the past from a utility standpoint. Even advent of air conditioning and things like that didn't change load to that extreme level, and especially not in existing footprints in brownfield areas. And the fact that a lot of these are in brownfield, urban or suburban areas that are already built out really adds to that density, because now there's another truck stop across the street and there's another distribution center across the street. And each distribution centers has a 10 times increase in load, so it starts adding up. So I guess one thing I learned, just the appreciation for it, when it gets into medium heavy duty trucking, it is something that utilities are still having to figure out. What's the best way from a process and planning standpoint?
I remember attending an EPRI event. We were in Savannah. And one of the sessions was it was simply titled "Trucks Aren't Buildings," and it made me actually attend it because I was curious about it. Something I'm curious about is, how does the speed of charging influence the challenge at these sites, whether it's a depot or truck stop? So a lot of talk about megawatt charging. Tesla's already out with their 750 kilowatt Tesla charging, and they're talking about doubling that, or the truck could possibly take 1.5 megawatts of charging speed. There's the overall energy use at a site, and then there's the kind of instantaneous flow. How significant is megawatt charging versus 150 kilowatt?
Yeah, one of the things, and we've talked through the years of the terminology and semantics of the industry, they'll say, all right, if you want to know if somebody has a utility background or a trucking background, ask them what a transmission means. And, there's a lot of things like that. So one of the things that the trucking industry and those who without a utility background, electricity background, understanding of the interaction of power and energy is very important. Trucking understands horsepower versus gallons of fuel, and that's sort of the difference in power and energy. Energy is the total energy, because the equivalent to how many gallons of diesel fuel do you need, and that's in kilowatt hours. So that's how much electrical fuel is needed. But what the electric system is based on is really the power. What is that power needed at any moment in time, which is the energy flow in a certain duration. Just like a truck may need to be sized. All right, what is the maximum horsepower needs dictates the engine that you're going to spec for the vehicle, which impacts a lot of other things. In the utility industry, it is at highest power level. So if you have a truck that, let's say you have a truck that has 500 kilowatt hours of energy consumption that's needed to refuel for a trip. If you have a long dwell time of 10 hours to do that in an overnight shift, that's 50 kW. So the power, the transformers, the conductors, and everything can be sized based on 50 kW per truck. But if you're in a slip seating arrangement, you need to get that 500 kilowatt hours done in 1 hour. 500 kilowatts, it's just math. It's just algebra. 500 kilowatt hours divided by 1 hour, that's going to be a 500 kW power load. And so 500, so now the transformers and everything need to be sized for that. So that's the local, but then, all right, what time of day is that based on? There may be some situations where 50 kW in the middle of the afternoon may be harder for the utilities to supply than 500 kW at night when the rest of the loads on the system are down. So it's that power is the component, the parameter that dictates the size of the equipment that utilities must install. But the time that happens is also very important, which gets into the managed charging, because you have the maximum amount will dictate the on-site needs. But when you get into the off-site, does the circuit need to be upgraded? Does the substation need to be upgraded? That's where the time of day really comes into play. and will you have managed charging, and how quickly do the different things change?
I think I think you bring up really good points, and this isn't, it's different language, it's different metrics, but if you just come back to its basis, it becomes simpler. There's probably a lot of things in life, right, where when you just get to the facts, but I think there's a fair amount of education we need to do. I see it all the time, and you do too, where utilities or in trucking are trying not to ask the stupid question of one another, but they don't really understand each other yet. So we got a period of time here where there's going to be a lot of education, learning, electric trucking, electricity 101, trucking 101, electric trucking 101. We just got to work our way through that over the next years. And then, some of these actions and discussions and collaborations will get easier because we'll have that more common understanding that we just don't have today. It's really,
Yeah. It's interesting you mentioned EV 101. It's been, I can't remember, I lose track of time, especially with the COVID 5 years. But so probably 7 or 8 years ago, I was actually in Columbus, Indiana, at your former employer doing a EV 101 session for a group of Cummins folks as they were trying to understand Duke Energy, serve that part of Indiana. So I was up there, and it's interesting. I designed something that I thought would be kind of a 30-minute walkthrough. Here's how rates work. Here's how this and that. It was a rates 101, I guess, more than anything, from a utility perspective. How do we, because everybody questions, what's a demand charge? What's a, so what I thought would be a 30-minute explanation of how rates worked and how trucking needed to understand that, it was well over an hour, and I don't think we got halfway through it. And you ended up doing a rates 101, EV 101 from utility standpoint at a TMC event a few years ago. And it is that the communication and the collaboration is going to be very important, more so than probably anything else I've been involved with.
Mike, let me ask you a real direct way. If you were like king of all this, maybe you are, but if you were king of all this and you wanted to say, okay, trucking fleets do this now, either to prepare for the future or to start, deploying electric trucks now, what's something that is like urgently needed by the fleets, the trucking fleets to is it this education? Is it something else? I mean, what is it that it would be the best use of our time right now, given that this is our future?
I think it's related to that education / and that coordination with utilities, get to know your utilities. I can't leave this without a quick plug on some of the things EPRI is doing, like the e-roadmap and grid fast. And that's really all about how fleets can help the utility do a better job of serving them. How do we get better information into utility planning? How do we get better certainty? I mentioned earlier, we're both regulated entities. That information, that coordination from fleets helps utilities as we engage with regulators and policymakers. It's one thing for a utility to say, hey, this load's coming, we need to build for it. Regulators are naturally skeptical of utilities trying to gold plate the system and things like that. It's one thing for the utilities to say it's coming. It's another to be able to say, look, here is the data, here, a list of all the top fleets, and this is what they are doing. So that information, it gives more certainty to the utility executives that are making decisions. It gives more information to the regulators and the policymakers. Because to make this happen, we are going to have to collaborate. This is a different load. We need to be more proactive. We need to get ahead of it. That information from fleets that we can help disseminate to all the utilities and to regulators is very important.
The one thing that really struck me was when we were talking about trucking and electricity. We talk about how different they are, but they really are similar in lots of aspects. So thank you for all of those comments, and I appreciate you joining me.
I've enjoyed the conversation. Thanks a lot, and I'm sure I'll see you soon.
Freight Efficiency with NACFE's Mike Roth and Friends.